Hi guys, once again, welcome sa Basic Operating System with Networking at welcome sa week 11 ng ating subject. So ngayon ang pag-uusapan natin ngayon ay tungkol sa internet infrastructure. Okay? Physically and logically dividing a large network. Okay? You can divide a network using two approaches. You can physically divide the network using hardware device, and you can logically divide the network using software settings. The first approach is called segmenting and the network, and the second approach is called subnetting. Bridges and switches. Bridges and switches are more intelligent than hubs and make decisions involving whatever to allow traffic to pass or where to route that traffic, reducing traffic on each segment and improving network performance. A routing table is a database stored within a router that is used to find the best network path on which to forward information. A network bridge keeps routing tables for each network to which it connects. So dito kasi sa bridges at saka switches natin, compare natin sa mga hubs natin, yung sinaunang hub na tinatawag, ay medyo malaki yung diferensya. Kasi yung hub natin noon, kumbaga ang ginagawa niya is i-connect ka lang niya, pero hindi na niya hindi kanya kumbaga ihanapan ng mas magandang daanan. Yan. Unlike sa mga bridges at saka switches natin, meron siyang tinatawag na allow traffic to pass or where to route that traffic. Kumbaga, ililihis ka niya sa traffic. O kaya, i-reduce niya yung traffic. Ganon yung bridges at saka switches. So, lahat naman sa sa network hindi naman natin maiiwasan yung traffic, 'di ba? Kasi lalo na marami yung gumagamit. Pero dito sa mga switches sa mga bridges na 'yan, kumbaga nire-reduce niya. Yan. The tables start out empty and all data packets that reach the bridge from one segment are passed on to the other segment connected to the bridge. Just like bridges, switches keep table of the MAC address of all the devices connected to the switch. Switches use these tables to determine which path to use when sending packets. However, unlike a bridge, a switch passes a packet only to its destination segment instead of to all segments other than the one it came from. Bridges and switches uses MAC addresses to subdivide a network into physical segments. Okay? However, all the segments are still logically a single network because each host is communicating with other hosts in other segment using the MAC address rather than the IP address. As far as a host is concerned, it is not aware that a bridge or a switch exists in a network. So, yung subnetting naman is a large network can be logically divided into two or more networks based on IP addresses rather than MAC address to reduce congestion. So each division is called a subnet and the process is called subnetting. So yung isa physically na dinidivide niya yung network using the switch, the hub, or yun yung tinatawag na segment, okay? From one network to another network. Say using the switch, the bridge, or the hub. Pero ang advice sa nagagamitin ay yung bridge o kaya yung switch. Okay? So kaya pag kukonect tayo ng network, so ang gagamitin natin either switch or a bridge. Okay? Kasi yung bridge, kumbaga, siya yung magdugtong sa dalawang network. Example, sa isang department to another department. Yun. Siya yung tulay para makapag-communicate yung dalawang department o dalawang network. And that is called subnetting or segmentation. Okay? Dito naman sa subnetting, ang ginagamit dito is yung configuration o yung software. Kumbaga, o yung IP address or a MAC address. Okay? So, yan yung discuss natin ngayon. Subnet mask, how does the host know if a remote host is on the same network? An IP address is made up of the network ID and the host ID. The host is told what portion of the IP address identifies the network by an entry in the TCP/IP configuration settings. This entry is called the network mask or subnet mask, and is used to define which portion of an IP address identifies the network and which portion identifies the host. Okay? The network mask is a group of 4 8-bit numbers separated by period. Okay, yan yung example ng subnet mask or network mask. Octet, yan, 1, 2, 3, 4. We have 4 octet. Isang network at 3 host. So yan yung class A. Class A network. Okay, yung classification ng network natin, ng IP address. Yan. Then the class B network, 2 network and 2 host. Okay? And sa class C, yung ginagamit natin sa mga small business or small enterprises, yan, network, we have 1, 2, 3 octet or tawag yan. And we have yung last na octet, yan siya yung host. Okay? And the network portion and host portion of each class of IP address. Yan yung network portion. Okay? Part of IP address. Okay? In each classification. Okay? Yan. If the network IDs had been different, the host would not have attempted to resolve the IP address to the MAC address, but would have sent the data to the gateway to its network. Eh yung MAC address kasi, automatic na binibigay yan ng network, binibigay yan ng computer. Okay? So yun yung siyempre sa dami naman ng mga numbers, hexadecimal numbers, yan. So 'di ba yung yung IP address is decimal numbers pero yung MAC address kasi combination. Okay? Characters and numbers. Okay? A gateway is any device, typically a router that provides access to another network. Subnet masks usually are not displayed as 32 bits separated by period as they are in tables. Yeah. Selecting a subnet mask A network engineer carefully select a subnet mask based on the number of subnets he needs and the number of hosts planned for each subnet. Subnetting is necessary when a large company is using a Class A, B, or C license for its entire network and want to use that one license over several networks to prevent network congestion. Okay, so yung mga large company daw, pwede silang gagamit ng Class A, B, or C para hindi mag-congest yung network nila. Okay? Ay hindi mapuno. Okay? Hindi magkaroon ng traffic, mga ganun. Now, how data travels across interconnected networks? A router is a stateless device, meaning that it is unconcerned about the data that it is routing, but it is concerned about the destination address of that data. Okay? Yung router kasi, ano ba yung gamit ng router? Di ba? Yung router, hindi siya concerned about the data that it is routing, but ang concern niya is about the destination or address of that data. Okay? Hindi niya concerned kung ano man yung data na iro-route niya, pero yung destination, address, yun ang concern niya. Saan ba niya idadaan, saan ba niya dadalhin yung data? Diba? Networks are connected by routers, which belongs to more than one network. Yan. So sa network kasi, either routers o kaya switch, yan. Para magkaroon ng more than one network, more than one computer connected to a network. So gagamit tayo ng router, gagamit tayo ng switch, o to connect to another network, gagamit tayo ng bridge or bridges. Now, ito yung kung paano na nagta-travel yung data sa across interconnected networks. Yan. The internet is a wave of interconnecting yet independent network. So, example, sa network A, papunta sa network F, o kaya sabihin na natin na web server in New York. Okay? Yung network A, siyempre, meron tayong tinatawag na router of network B. Yan, router 1, router 2, router 3, router 4, router 5, router 6, router 7, and router 8. So, ilang router na yan? So, lahat kasi ng network, yung dito sa diagram natin, every network meron silang sariling router. Okay, sabihin na natin na iba't ibang bansa yung yung mga network na yan. Network A, network B, network C, network D, E, and F. So ibig sabihin, yung mga router na yan dapat meron siyang connectivity para makapag-communicate sila, di ba? From router 1 to router 2, router 2 to router 3, or router 1 to router 3, mga ganon. Yung router 2 connected kay router 4 at saka yung router 3 connected kay router 4. So yung router 4, sabihin natin na sa gitna siya, yung 5, 6, 7, and 8 ay connected sa kanya. Pati na rin yung 2 and 3. Yan. Ganon din lahat. Kumbaga, connected sila sa isa't isa. Kahit na sabihin na natin na hindi magkakakilala yan, once na yung isa ay in-access yung isang data, or yung isang file, yon. Kasi sa internet kasi, hindi naman natin alam talaga kung anong network yung galing o kaya anong ano yung address, okay, galing yung isang data or information na dina-download natin. Okay? Alam natin yung yung browser na ginamit natin, pero yung computer na pinanggalingan nun or yung IP address or yung ISP na pinanggalingan nun ay hindi natin alam. So doon sa internet kasi iba-iba yung yung nagda-download diyan, iba-iba yung nag-upload. So yun yung tinitignan naman ng mga internet provider natin. 'Di ba? So every every network, every computer meron siyang sari-sariling router. So yun yung hinahanap ngayon ng doon dumadaan. Okay? At yung router naman siya yung kumbaga naghahanap ng daan ng magandang daan para ma-send yung data or information na nire-request ng isang network. Di ba? So ganun yung niyan, yung kung paano nagta-travel yung data sa internet across the land. Okay, across the Philippines, from country to country. 'Di ba? So yan. So routers are responsible for helping data travel across interconnected networks. Yan yung ginagawa ng routers natin. A router can forward data to the correct network in a way that is similar to a switch method. A router uses the most efficient path available to forward packet to their destination, which may be located across a great geographical distance. Yan. So of course, pag gumamit kasi tayo ng router, na alam na natin na meron tayong tinatawag na internet, 'di ba? Ganun naman yung yung alam natin, 'di ba? Pag gumamit tayo ng router, connected na tayo sa internet kasi yung router meron siyang built-in modem or modulate demodulation system. Ba? So yung internet connection natin directed na siya sa router. So nandun na yung modem niya, nandun na yung LAN network. So pwede na tayong mag-connect sa internet. A router can transmit a data packet to a remote network only if the higher layer protocol that was used to produce the data packet can be routed to a remote network. A router, short for bridge and router, function as both a bridge and a router. Kumbaga combination of bridge and router. The device can forward routable protocols including TCP/IP and IPX, SPX packet. And in these cases, it working as router. Yan. So combination na siya. Iisa lang siya pero nandun na yung bridge at saka router, yung tinatawag na browser. Packets that are not routable such as NetBEUI packets are forwarded to other local networks in the manner that a bridge would forward packet. Like switches, routers use tables to determine the best route by which to send the data to its destination. When routers communicate with other routers to build routing tables and determine availability of routes, one of the several protocol is used. Yan, yung mga protocol na yan. RIP, OSPF, BGP, yan. Yan yung mga protocol na ginagamit. Yan. TCP/IP routing. Okay, transfer control protocol or IP address routing. Suppose a host computer wants to send data to another host. Remember that the host uses its subnet mask to decide if the destination host is on its own or another network. If the first host knows that the remote host is on its same network, it must discover the MAC address of the remote host. If the sending host determines that the remote host is on a different network, it sends the data to the router, which is serving as a gateway to remote network. When the packet arrives at the router decides if the packets belong to the host within its own local network or needs to be routed to a different network. Yan. So, ganun yung TCP/IP routing. So, yung IP address, yon binabasa ng router, binabasa ng computer, kung para sa kanya ba o hindi yung data na sinesend. Okay? Kapag yung yung IP address ay hindi pareho sa source, yon babasahin niya ng network at dadalhin niya sa iba. Kumbaga, yan. The router decides if the packets belong to the host within its own local network or needs to be routed to a different network. Yan. So kapag hindi niya nabasa, yan, i-route niya into another network. So routing across many networks. For routing across interconnected network, each time a packet encounters a router, its TTL is reduced by 1. If the router must send the packet over a network that cannot handle large packet, the router divides the packet into smaller packets. Yan. So, meron kasing example yung mga packets, yan, or yung handle, ang tawag doon, yung large packet na tinatawag, ano ba yung packet kasi na yan? Okay? Yung packet na yan ay yung kumbaga yan yung daan o kaya siya yung nag-handle ng ng mga data. Okay? Yun yung kumbaga ito yung mga formatted data at ready for transmission. Yan yung mga data na ready sa transmission. Okay? Ready nang i-send sa network. Pero kapag yung packet ay medyo mabigat o kaya hindi niya kayang i-hold, okay? The router divides the packet into smaller packets. Okay? Hati-hatiin niya yan. Yun yung ginagawa ng router. Hindi lang niya dinadaan sa magandang daan, kundi nire-remedyo pa niya kung example kung mabigat, siyempre hati-hatiin mo yan para mas madali mong i-travel. Ganun yung router. Yung default gateways naman natin, sometimes a large network has more than one router. Yan. So the network has more than one gateway to other networks. So ano ba yung gateway na yan? The network in the upper left, yan, and has two routers D and E, each of which also belongs to other network. Host is designated as a default gateway, meaning that host on the 250.1 1.2 network send packet address to other network to this gateway first. The other router had host D is called an alternate gateway and is used if communication to the default gateway fails. The domain names are assigned because IP address numbers are difficult to remember and because companies might want to change their IP addresses without also changing the internet name by which the outside world knows them. Okay? The large segment of suffix of a domain name is called the top label domain and tells you something about the function of the host. The first word in the domain name is issued in identity, a subcategory within the domain and is called a canonical name or CNAME. Yan. So assigning and tracking domain names and IP address. Okay. The organization responsible for overseeing this operation is the IANA or the Internet Assigned Number Authority. Yan. Beginning in the spring of 1999, the responsibility for assigning and tracking domain names and IP address or addresses was transitioned from IANA to a non-profit private sector's organization regulated by the U.S. Department of Commerce called ICANN or the Internet Corporation for Assigned Names and Numbers. So ibig sabihin, sila yung nag-manage sa mga IP address natin, MAC address at saka MAC address. Okay, sa network, sa internet. A company that can register these names and numbers must be approved by ICANN and is called a registrar. Okay, kumbaga sila yung registrar ng internet. Kailangan na i-register mo yung name. Yan, yung mga routable IP address, yung MAC address. Yan. So sila yung namamahala. Domain names and IP addresses do not have to be permanently related. Yan. Two name resolution services track relationship between domain names and IP addresses or DNS or domain name system, also called domain name service, and Microsoft Windows Internet Naming Service. The DNS is the more popular of the two because it works on all platforms. Okay? At the heart of DNS is a distributed database which initially must be created manually. So, yung DNS kasi at saka yung WINS na tinatawag, yung Windows Internet Naming Service, yung domain name ang popular kasi lahat ng platform, lahat ng operating system pwedeng gamitin ito. Unlike sa Windows Internet Naming Service, kung saan yung Windows or yung Microsoft lang ang gumagamit. Diba? Yung Windows natin, Microsoft may-ari. So sila yung pwedeng gagamit. Pero pag DNS, either Mac OS, iOS, Windows, pwedeng gamitin. Kaya yan yung domain name system or domain name service natin. How DNS works? DNS has three logical components. Computer searching for the IP address for the domain name called resolvers and the servers that contains the information related domain names to IP addresses called name server and the database or databases of information needed to resolve domain names and IP addresses called namespace. The process of discovering an IP address for a given domain name is called address resolution. It is also possible to find the domain name for a given IP address. This process is called reverse resolution or reverse mapping. Name servers are organized from the top down as Yan. Network solutions maintain server called root servers that act as the highest level of authority when locating domain name information. A network that supports DNS has two or more name servers called the primary name server and secondary name server, which the secondary server gets its information from the primary server and it's sometimes called the slave name server. The authoritative name server is the server that has the most current information about a domain name. Kumbaga siya yung pinaka-update. Yung secondary server naman, sometimes called the slave name server. Kumbaga slavery siya. The group of network for which the name server is responsible collectively is called the name server zone. And zone also can be caching only server that does not keep authoritative information but only caches information as it is used in case of it's needed again within a short period of time. Yan. So yan yung DNS records. Its name server holds a piece of the namespace, which is the database containing information needed to resolve domain names and IP addresses. A name server keeps the entries for each domain name that it knows about in a records or resource records or DNS record. And so yan yung about internet infrastructure, DNS, ano pa? Yung domain names on the internet, gateways, routers, bridges, hubs. So yan yung mga kung paano ba hinahati yung mga network. So, 'di ba dalawa ulitin natin, dalawa yung paraan kung paano hatiin ang network. The subnetting and segment, okay? Segmentation. Okay? Yung segmentation or segment yun ay through physical or devices. Physical division. Okay? So, device yung gagamitin. Pero sa subnetting, through IP address and or MAC address. Okay? MAC address. So, yung dalawang component na yon, IP at saka MAC address, automatic yan. Pwedeng automatic na i-assign ng computer, ng network, o kaya pwede naman na manually assign. Okay? So, yung automatically, pag ulitin natin from the previous lesson natin ng IP address, yung IP address natin pag gumamit tayo ng DNS o yung DHCP na tinatawag, automatic yan na i-assign ng server. Okay? So mag-determine lang tayo na kung ano yung umpisa ng IP address at saka yung end niya, yun bahala na yung network o yung server na mag-assign ng IP address. Ganon din sa MAC address. Okay, so yan. Sana naintindihan nyo, may naintindihan kayo dito sa topic natin na to. So hanggang dito na lang at yun, lagi nating paalala, okay, yung mga tawag doon, yung mga activity natin na hindi pa naipapasa, ipasa nyo na, okay? Para ma-check at mabigyan na kayo ng grado. At saka yung mga activity, yung mga answers naman lahat yan, nasa ano yan, nasa module natin. Wag basta basahin nyo lang, nandun lahat. So, intindihin nyo lang siya, intindihin nyo lang yung module, basahin nyo para masagot nyo ng maayos yung mga activity na yan. So yan, maraming salamat at God bless. Yan. And goodbye.